Hello viewers, welcome to another episode of Knowledge Shared. Before continuing, like us, like and follow our Facebook page, subscribe to our YouTube channel, comments and share video for more interesting topics. Today we are looking at this question and it says if a plus b equals to 1 and a to the power of 2 plus b to the power of 2 equals to 2, find a to the power of 11 plus b to the power of 11. So in this case, we are going to find the solution of a to the power of 11 and b to the power of 11. We have here solution. We are given a plus b equals to 1 and also a to the power of 2 plus b to the power of 2 equals to 2. Let's call this equation 1 and let's call this equation 2. We are asked to find a to the power of 11 plus b to the power of 11. What is the value of this? So the first step that we are going to take, step 1, we have a plus b equals to 1. So we are going to square this, or we do it this way. We say square both sides equation 1. So this will become a plus b all to the power of 2 equals to 1 all to the power of 2. So this is what it means. We are squaring equation 1. So this is the same thing as, we all know that a plus b to the power of 2 is the same thing as a to the power of 2 plus b to the power of 2 plus 2ab. When we express this in this format, then all will be equals to 1. So here we can group the power of 2 to one side and move this to this other side. We can see that we have a to the power of 2 and b to the power of 2. Then from equation 2 here, we have a to the power of 2 plus b to the power of 2 equals to 2. So the whole of here will become 2. Then we bring down plus 2ab equals to 1. We can make 2ab or ab the subject of this expression by transferring this to this other side. So this will become 2ab equals to 1. When 2 transpose into this other side, it becomes minus 2. Therefore, 2ab equals to minus 1. In this case, we can make ab the subject of this expression by dividing all through by 2. This is divided by 2. 2 cancels here 1 and 2 cancels here 1. Therefore, ab equals to minus 1 all over 2. We call this equation 3. So in this case, we have equation 3. Then we are going to move to step 2. So at step 2, we have, still from equation 1, we will square or apply cube root to equation 1. So we have equation 1 here. So it will become a plus b all to the power of 3 equals to 1 to the power of 3. We all know that a plus b to the power of 3 is the same thing as a to the power of 3 plus b to the power of 3 plus 3a to the power of 2 times b plus 3a times b to the power of 2. So this is what it means. All equals to 1 because 1 to the power of 3 is 1. So in this case, we can expand this because we have 3ab is common to this. So we can factor it out. So we have a to the power of 3 plus b to the power of 3 plus 3ab into, where we have here, this is b plus, we have here a equals to 1. So in this case, this is the same thing as a to the power of 3 plus b to the power of 3 plus 3ab into a plus b all equals to 1. So we can see that we have a to the power of 3 and b to the power of 3. So here we have ab here, and the value of our ab for equation 3 is minus 1 all over 2. So we have also a plus b, and from equation 1, a plus b is 1. So we are going to substitute that into this expression. So we have a to the power of 3 plus b to the power of 3 plus 3 into, we have ab as minus 1 all over 2. Then we have a plus b as 1. So it's going to be times 1 equals to 1. So in this case, a to the power of 3 plus b to the power of 3 plus, this is 3 times minus 1, it's going to be minus 3 all over 2 times 1 equals to 1. So in this case, this can be transposed into this other side. We have a to the power of 3 plus b to the power of 3 equals to 1 plus 3 all over 2. So here we can add this. If this is, we have LCM as 2. 2 divided by 1 is 2. So we have 2. Then 2 divided by 2 is 1. 1 times 3, we have 3. Therefore, we have a to the power of 3 plus b to the power of 3 equals to 2 plus 3 equals to 5 all over 2. So this is what we have. We ended the last one with equation 3. So this becomes equation 4. So from here, we have here step 2. We have here step 3 will be, we are going to multiply step 2 and step 4. We say multiply equation 2 and equation 4. So that means our equation 2 is a to the power of 2 plus b to the power of 2 equals to 2. Then we multiply by a to the power of 3 plus b to the power of 3 equals to 5 all over 2. So this will become a to the power of 2 plus b to the power of 2 into a to the power of 3 plus b to the power of 3 equals to 2 times 5 all over 2. So here we are going to expand this parenthesis. A to the power of 2 times a to the power of 3 will give us a to the power of 5. A to the power of 2 times b to the power of 3 will give us plus a to the power of 2 b to the power of 3. This time this will give us plus a to the power of 3 b to the power of 2. B to the power of 2 times b to the power of 3 will give us plus b to the power of 5 equals to, we have 2 times 5 is 10, or as well 2 will cancel here 1 and 2 will cancel here 1. This will be equals to 5. In this case, we can see that we can factor this out because we have a to the power of 2 here and we have b to the power of 2. So a to the power of 2 and b to the power of 2 can factor this out. So we have a to the power of 5 plus b to the power of 5 plus we have a to the power of 2 plus b to the power of 2 into, when we divide by here we have b plus, when we divide this by this we are going to have a all equals to 5. So in this case we can interchange this as a plus b is same thing as b plus a. So this will become a to the power of 5 plus b to the power of 5 plus a plus b all to the power of 2, because this is what this becomes, into a plus b all equals to 5. So this is what we have. And we can see that ab is, we have ab at minus 1 all over 2. And we also have a plus b as 1. So we are going to substitute that into where we have this. So we need to clean this. We are going to spell out our equation 1 to 3 so that we are going to use it subsequently. So we have this. So now from here we said that we have a to the power of 5 plus b to the power of 5, then plus we have ab to the power of 2, because ab to the power of 2, ab is, we have it is going to be plus minus 1 all over 2 all to the power of 2. That is what it means, times we have a plus b is 1 from equation 1 equals to all equals to 5. We can move the constant to one side. So here will become a to the power of 5 plus b to the power of 5 equals to 5 minus. This is the same thing as minus 1 squared is going to be 1 all over 4. So here we find the LCM. LCM is 4. So this is the same thing as 5 all over 1. 4 divided by 1 is 4. 4 times 5 is 20. 4 divided by 4 is 1. 1 times 1 is minus 1. So this will become a to the power of 5 plus b to the power of 5 equals to 20 minus 1 is 19 all over 4. This will become our equation 5. So we have this as equation 5. So the next step is for us to, we move to step 4. Then from equation, we say from equation 4, we are going to square both sides from equation 4, because all our aim is to find a way to have a to the power of 11 plus b to the power of 11. So in this case, from equation 4, which is a to the power of 3 plus b to the power of 3 equals to 5 all over 2, we are going to square both sides. So this is all to the power of 2 and this is all to the power of 2. In this case, we can expand this. So we have a to the power of 3 plus b to the power of 3 into a to the power of 3 plus b to the power of 3 equals to 5 all over 2 to the power of 2 is the same thing as 25, because 5 to the power of 2 is 25 and 2 to the power of 2 is 4. So in this case, expanding this, a to the power of 3 times a to the power of 3 is a to the power of 6. A to the power of 3 times b to the power of 3 will give us a to the power of 3, b to the power of 3. Then b to the power of 3 times a to the power of 3 will give us plus a to the power of 3, b to the power of 3. Then b to the power of 3 times b to the power of 3 will give us b to the power of 6 equals to 25 all over 4. This is the same thing as a to the power of 6 collecting like terms plus b to the power of 6 plus 2. This is a to the power of 3, b to the power of 3 equals to 25 all over 4. So this is what we have. And this is the same thing as a to the power of 3 times b to the power of 3 is ab all to the power of 3. So this will become a to the power of 6 plus b to the power of 6 plus 2 into ab all to the power of 3 equals to 25 all over 4. So here we have ab here, and from equation 3 here, our ab is minus 1 all over 2. Substituting that into here, this will become, so we need to clean this. Then we, as we said, we have a to the power of 6 plus b to the power of 6 plus 2. So we said our ab is minus 1 all over 2. It's going to be into minus 1 all over 2 all to the power of 3 equals to 25 all over 4. So in this case, this will become a to the power of 6 plus b to the power of 6 plus 2 into, we have, this will become minus 1 all over 8 equals to 25 all over 4. Because minus 1 to the power of 3 is minus 1. Then 2 to the power of 3 is 8. That is what we have. We can transfer all the constant to one side. So this will become a to the power of 6 plus b to the power of 6 equals to 25 all over 4. Then this will become 2 times minus 1 is minus 2. So when it crosses this side, it becomes plus 2 all over 8. So here, finding a LCM of these two is, the LCM of the two is 8. 8 divided by 4 is 2. 2 times 25 is 50. We have 8 divided by 8 is 1. 1 times 2 is plus 2. This will become a to the power of 6 plus b to the power of 6 equals to 50 plus 2 is 52 all over 8. So in this case, 2 will cancel here 4, and 2 will cancel here 2, 2 will cancel here 6, 2 will cancel here 2, 2 will cancel here, we have 13. So in this case, we have a to the power of 6 plus b to the power of 6 equals to 13 all over 2. So this is what we have, and this is our equation 6. We have that as the 6th equation. So the next one is going to be step, we have here step 4, it's going to be step 5. In our step 5, because our aim is to find a to the power of 11 plus b to the power of 11, and we've gotten a to the power of 6 here, and we had a to the power of 5. If we multiply the two equations together, 6 and 5, if we multiply in indices, it's going to be 6 plus 5 gives us 11. So we are coming down to our solution. So in this case, we are going to multiply this equation and this equation. Here we will say multiply equation, this is equation 5 and equation 6. So in this case, this will become a to the power of 5 plus b to the power of 5 equals to 19 all over 4. So we multiply by equation 6, which is a to the power of 6 plus b to the power of 6 equals to 13 all over 2. By multiplying that, this is the same thing as a to the power of 5 plus b to the power of 5 into a to the power of 6 plus b to the power of 6 equals to, we have here 19 all over 4 times 13 all over 2. So multiplying this out, expanding this parenthesis, we have a to the power of 5 times a to the power of 6 will give us a to the power of 11. Then a to the power of 5 times b to the power of 6 will give us plus a to the power of 5 b to the power of 6. b to the power of 5 times a to the power of 6 will give us plus a to the power of 6, then b to the power of 5. b to the power of 5 times b to the power of 6 will give us plus b to the power of 11 equals to multiplying this, 19 times 13 will give us 247. Then 4 times 2 will give us 8. This is all over 8. So in this case, we can collect like terms. So we have a to the power of 11 plus b to the power of 11 plus we have here a to the power of 5 and also b to the power of 5. So this will become a to the power of 5, b to the power of 5 into, because they are common, this will become b plus a equals to 247 all over 8. So in this case, we have a to the power of 5 here. We can factor it out. So we have a to the power of 11 plus b to the power of 11 plus a b all to the power of 5 into a plus b equals to 247 all over 8. So we clean this. Here, we can write this out. So we have a to the power of 11 plus b to the power of 11 plus a b all to the power of 5 into a plus b equals to 247 all over 8. So in this case, we recall that our AB is minus 1 all over 2 and our A plus B is 1. So we are going to substitute this into here. So we have a to the power of 11 plus b to the power of 11 plus our AB, which is minus 1 all over 2 all to the power of 5. Then we have our a plus b as 1 equals to 247 all over 8. We can see that we have a to the power of 11 plus b to the power of 11. So now we are going to move constant to one side. So we have a to the power of 11 plus b to the power of 11 equals to 200, or let's expand this, plus minus 1 to the power of 5 becomes minus 1. Then 2 to the power of 5 is the same thing as 32. So times 1 is 1 equals to 247 all over 8. So this is the same thing as a to the power of 11 plus b to the power of 11 equals to, when this move to this other side, it becomes positive. So we have 247 all over 8 plus 1 all over 32. So we are going to find the LCM of these two. So we have it as 32. So now 32 divided by 8 is 4. 4 times 247, we have 988. So we have 32 divided by 32 is 1. 1 times 1, we have plus 1. So in this case, our AB, this is the same thing as 989 all over 32. Therefore, our a to the power of 11 plus b to the power of 11 equals to 989 all over 32. So this is the value of our a to the power of 11 plus b to the power of 11, which is equals to 989 all over 32, and it satisfies this expression. If you like what we are doing here, follow us on our Facebook page, subscribe to our YouTube channel, comment and share video for more interesting topics. Thank you.